Hello everyone, this is Mr. V. Hill. Today we're going to be talking about projectile motion. But before we get to this, I want you to pause the video and go look at the notes that are available on the website. They're on the 5th 6 weeks page labeled PowerPoint Notes, or excuse me, Projectile Motion Notes. It's a PowerPoint slide show. So just go through that, look at the equations that are presented there and the graphs, try to understand what's going on with that. And then when you're done with that, come back here and I'm going to talk you through each of the examples that are presented in that PowerPoint. So pause the video now. If you haven't already done so, go read through those slides. Okay, you've read through the slides, so let's talk about these examples a little bit. First one was this one about Mr. Campbell just dropping a can of Spam off of a bridge that's 80 feet high. And we want to know, when will the Spam hit the ground? Well, the equation for falling objects was, of course, h, the height above the ground, is given by 1/2 times a, which is the acceleration due to gravity, times the square of the time that has passed, plus h sub 0, or h naught, which is the initial height. So since they give us the initial height in feet, we're going to use the acceleration due to gravity that's also using feet, which is the negative 32 feet per second squared. If this is meters, then we'd want to use the negative 9.8 meters per second squared for gravity. So here, really what we have here is, our equation is going to be h is equal to 1/2 times negative 32 feet per second squared times the square of time, which is going to be measured in seconds here, so time squared would be seconds squared. That's going to cancel out with the seconds squared on acceleration, plus the initial height of 80 feet. Or, if we just do this multiplication, h is equal to negative 16 times t squared plus 80. And so we want to find when the Spam is going to hit the ground. So we want to know the t value that's going to give us the height of 0. If we were to graph this equation, it would look something like this. Not exactly like this graph that was in the PowerPoint, but as time passes, the object is going to start at its initial height and then just fall to the ground. And it's going to speed up as it's going. Notice that the independent variable is time, not distance from where you dropped it or anything weird like that. Although it would look like this if you pushed an object off of a bridge. And then as time passed, the thing would start moving away from the bridge with that initial velocity. But that's for the next example with horizontal launch. But so what we really want to know is here, when is the can of Spam going to hit the ground? And that's going to be given by the t coordinate, the independent variable of the x-intercept. That's really what we're looking for. So we just want to know what the t value is that's going to give us an h of 0. So really all we're going to do is plug in 0 for h, and then solve for t. And that's pretty easy to do since there's no linear term here, or that b times t, or x, you know. All we have to do is undo what's being done to t in reverse order of operations. So first thing we got to undo is this adding 80, so we just subtract 80 from both sides. That is, of course, going to cancel out those. So we're left with negative 80 is equal to negative 16 t squared. Then we undo the multiplying by negative 16 by dividing both sides by negative 16. Negative 80 divided by negative 16 was going to be 5. These factors of negative 16 are going to cancel out, leaving us just with t squared on the right-hand side. And then we just undo the squaring by taking plus or minus the square root of both sides. That's going to get rid of our squaring. And so we're left with t on the right is equal to plus or minus the square root of 5. Now, we don't need to worry about the negative one. Time that is passed is never going to be negative. So we can just forget about that part, and we're just going to use the positive square root of 5. Of course, you're never going to tell somebody, oh, it took me the square root of 5 seconds to fall or to drop this thing, so we need to get an approximate value here. So just take the square root of 5, and that's about 2.24 seconds. So the time is going to be approximately 2.24 seconds. No big deal. For a horizontal launch, and the big thing here is that the horizontal motion and the vertical motion are independent of each other. So, if you want to know how long something's going to hit the ground when it's launched horizontally, all we really need to do is treat it like it was just falling. And so we're kind of in the same situation here. So of course, we're using our falling object equation. Height above the ground is equal to 1/2 a times t squared plus h sub 0. In this case, our initial height is going to be 80 meters. So that means we want to use the acceleration that is in meters per second squared. So h is equal to 1/2 times negative 9.8 meters per second squared times t squared plus our initial height of 80 meters. Or negative 9.8, half of that is of course just negative 4.9. And again, we want to know when it's going to hit the ground, so we want to know when the height is going to be 0. So really all we're doing is going to solve this equation for t. And again, there's no linear term, so we can just undo what's being done to t with opposite operations. First, we subtract 80 from both sides. Negative 80 is equal to negative 4.9 t squared. And we're going to divide both sides by the negative 4.9. So these factors are going to cancel out. And so t squared is going to be equal to, and now we're probably going to have to do an approximation here because I don't believe that 4.9 goes evenly into 80. So it's negative 80 divided by negative 4.9, which is about 16.327 looks like. So t squared is approximately 16.327. Of course, we don't want to know what t squared is, we want to know what t is, so we just take the square root of both sides, and we don't need to worry about the negative square root because time can't be negative. And so the approximate value for t is just going to be what we get when we take the square root of that 16.327, and we're going to get about 4.04 seconds. Wonderful. So that's how long it's going to take the can of Spam to hit the ground. But now while it was falling that whole time, it was actually moving horizontally. So if the initial velocity of the Spam, the horizontal velocity, is 120 meters per second, we want to know how far from the base of the cliff will be the point of impact. So that whole time that it's falling, it's moving horizontally at this rate. So that's where we're only going to use the fact that distance is equal to rate times time, because we know what the rate is in meters per second, and we know what the time is, 4.04 seconds. So the distance will be equal to the rate of 120 meters per second times this 4.04 seconds. It's nice because, of course, seconds will cancel out, leaving us just with meters. And so let's see here, 120 meters per second times 4.04 seconds. That gives us just 484.8 feet. Excuse me, meters. Now, let's move on to a vertical launch. So now, we're shooting the can of Spam straight up into the air, and so it's going to travel up to its maximum height and then fall back down to the ground. And we want to know, when is the Spam going to reach its maximum height? Well, the equation we're going to be using is, of course, that one for vertical launch. The height above the ground, h, is equal to 1/2 times a times the time squared plus v times t, where v is the vertical velocity, t is again time, plus h naught, which is the initial height. Here, since we're firing it from the ground, our initial height is going to be 0. Initial velocity is in feet per second, so we want to use the acceleration in feet per second squared. So our equation is going to be h is equal to 1/2 times -32 feet per second squared times time squared plus 96 feet per second times time, t, plus the initial height of 0. And now, if we want to know the maximum height, keep in mind that the maximum height is always going to occur at the vertex. So the parabola is going to end up looking like this. The vertex is right there, and the vertex is always on the line of symmetry. So if we want to know the time that's going to take to get to that maximum height, we need to find the line of symmetry, which will also give us the t-coordinate of that vertex. So here, if we rewrite this now, just with 1/2 times -32 is of course going to be -16 times t squared plus 96t. We don't need to write that plus 0. We just need to look at what a and b are. Here, a is going to be equal to -16. B is going to be 96. C is, of course, 0, but we don't need that for finding a line of symmetry. Remember, our line of symmetry is always going to be given by t, or x, the independent variable, equals -b over 2 times a. So, time is going to be equal to the negative of b, which is 96, divided by 2 times -16. And, well, you can't probably do that in your head, but -96 divided by -32 is, of course, 3, because 2 times -16 is -32. So the time it's going to take to get there is exactly 3 seconds. But now we want to know, what is the maximum height of the can of Spam? And all we got to do there is plug in that t value into the equation. So the maximum height we get just by plugging t into the equation. So this is going to be -16 times that time, 3 squared, plus 96 times 3. This is pretty easy to figure out, or we just punch it into our calculator. Either way, -16 times 3 squared plus 96 times 3, and we get 144 feet. Wonderful. But now, we want to know how long it's going to take for the can of Spam to fall back down from this height. But if we're really clever, we should notice we can make use of symmetry. So whatever time it takes to get up to the maximum height from the ground, it's going to take that exact same amount of time to come back down to the ground. So it's going to take another 3 seconds to fall back down. So 3 seconds to climb up, 3 seconds to fall back down, so the total flight time is going to be 6 seconds. Or we can use our equation, and we actually want to know when the height will be above the ground will be 0. So we'd be really wanting to solve this equation. 0 is equal to negative 16 times t squared plus 96 times t. And if we wanted to, we could use the quadratic formula on this. So of course, a is negative 16. B is coefficient of t, which is 96. And c is, of course, 0. So the x-intercepts are going to occur, or the t-intercepts really, when t is equal to negative b, which is negative 96, plus or minus the square root of b squared minus 4 times a, which is negative 16, times c, which is 0. All of that divided by 2 times a, which is negative 16. And so here, 4 times negative 16 times 0 is just 0. So really we get t is equal to negative 96 plus or minus the square root of 96 squared, which is of course just 96, all divided by negative 32. And so we get either, well, negative 96 plus 96 is going to be 0 divided by negative 32. So either t equals 0 or negative 96 minus another 96. Well, what's that going to be? Negative 192. We divide that by negative 32, and there's our 6. So when time equals 0, the thing was on the ground. That's when, because the time of 0 is going to give an h of 0. Or when t equals 6, the can's back on the ground. So because it starts on the ground, so that's where we get this solution, but it hits the ground again when time equals 6. Now, suppose that we're firing this off of a cliff. We're shooting it vertically into the air, but now what's going to happen is that the can of Spam is going to miss that cliff when it's falling back down. So what it's going to look like is this. Starting at 240 feet above the ground, we fire it vertically, time passes, the can of Spam is going to climb to its maximum value and then fall back down, but it's not going to stop at the top of the cliff. It's going to miss that edge of the cliff and fall all the way back down to the bottom of the canyon or whatever this thing is. So we want to know when the Spam is going to reach its maximum height. Again, we need to find the line of symmetry or the t-coordinate of the vertex. But first, let's write out our equation here. So the height above the ground is given by 1/2 times a times t squared plus v times t plus h naught. Since the initial height is given in feet, we're going to use the acceleration given in feet per second squared. So h is equal to 1/2 times negative 32 times t squared plus the initial velocity, 128 feet per second, times t plus your initial height of 240. Or just simplifying this here, h is equal to negative 16 t squared plus 128 plus 240. And so the line of symmetry, or the amount of time it's going to take for the Spam to reach its maximum height, is just given by, well, let's identify here, a is equal to negative 16, b is equal to 128, c is equal to 240. line of symmetry is given by t is equal to negative b over 2 times a, or time is equal to negative 128 divided by 2 times negative 16, and that is, of course, 4. So it's going to take 4 seconds for the can of Spam to reach its maximum height. Now, of course, we want to know what the maximum height of the can of Spam will actually be. So all we got to do now is plug that 4 seconds back into the equation. Remember, our equation was h is equal to negative 16t squared plus 128t plus 240. We just plug the 4 seconds back in there to give us our maximum height. So it's negative 16 times 4 squared plus 128 times 4 plus 240. And we can just punch that into our calculator as well. Let's see here. Negative 16 times 4 squared plus 128 times 4 plus 240. Oops. And so we get a maximum height of 496 feet. Excellent. Now we want to know the total flight time. So how long is it going to take for this thing to fall back to the ground? And now this thing is not symmetric anymore, so we can't just say it's going to take another 4 seconds for it to fall back down. Now we do have to solve the actual equation for when h equals 0. And again, our equation was negative 16t squared, h equals negative 16 times t squared, plus 128t plus 240. We want to know when the height is 0, so really we're solving this equation. So of course, a is negative 16, b is 128, and c is 240. So all we got to do is use the quadratic formula, which tells us that t equals negative b plus or minus the square root of b squared minus 4 times a, which is negative 16, times c, which is 240. All of that divided by 2 times a, which is negative 16. And so what we can do now is just punch this all into the calculator. You don't have to do it twice, once for plus and once for minus. But, so we got in parentheses now for our numerator, 128 plus the square root of 128 squared minus 4 times negative 16 times 240, parentheses around my numerator, and then we're going to divide that by 2 times negative 16, which is negative 32. And there we go, negative 9.567. Oh, wait a second here. I think I missed a negative sign up there. Easy enough to fix. Scroll back over here and insert my negative sign. That looks better. So t is going to be approximately negative 1.568 seconds. Oh, but that doesn't make any sense because time can't be negative. So really the solution we wanted was the one with the minus in it, right there. So let's bring that up and just change our plus to a minus in there. Now hit enter. And so or t equals, or is approximately equal to 9.568 seconds. And that's a much more reasonable answer because, well, yeah, time should be positive. And that's about it for projectile motion. Hope you enjoyed it.